Learning Objective A, we're going to look at writing complex numbers and finding complex conjugates. Before we start looking at computations with complex numbers, let's talk about where they fall in the family of numbers. Complex numbers are at the top of everything. They include two different types of numbers, real and imaginaries. The imaginaries we're going to talk about in a bit are the square roots of the negatives. The reals are the numbers we can see. It's a number you can put on the number line. Now, any number that can be put on a number line is either considered rational or irrational. Rational just means it's a number I can write as an integer or a fraction. Irrational are those that cannot be written as a fraction, such as the number pi. Now I stated that the rational numbers here were made up of integers and numbers that are written as fractions. So they're going to break it down and just talk about the specific integers. So those are positive and negative whole numbers, including 0. And then below that are the natural numbers. These are just the positive integers, including 0. So we're going to focus on the rest of the chapter, what if we have complex numbers? One thing you want to recall from Algebra 2 is the imaginary number and a complex number. So the number I is an imaginary number. It is actually made up of a complex number. A complex number is a real component and an imaginary component. We're going to talk right now just about the imaginary component. So recall that I is equal to the square root of a negative 1 because we call square roots of negatives imaginary. So here's what they want us to do. Verify that f of x has two zeros of I and negative I by evaluating x squared plus 1. So they want to verify that x squared plus 1 has two zeros that are imaginary. To find the zeros, remember we just take the expression and set it equal to 0. So to solve, we're going to subtract 1 from both sides. It means we get x squared equals negative 1. You come in and take the square root, and you're going to get x equals the square root of negative 1. Now, be careful. Notice this notation. They're saying it's a plus and a minus. So do not forget right here that it is plus and minus. The reason I know that is because I'm solving a quadratic. Whenever you solve a quadratic and come in and take the square root, when you do this step, it's always plus and minus. So now we're going to add that down below too. Now, whenever you see the square root of a negative 1, we are now going to replace that with the letter I. So therefore, this answer simplifies to plus or minus I, which can be written like this, compounded together, or it could be written separately as I and negative I. Now they want us to go in and show that if we take the square root of negative 5, we get this value right here. So let's just go ahead, the square root of negative 5. Now the reason they want us to do this problem because they want us to realize that we can rewrite negative 5 as negative 1 times 5. And then we can pull that apart as a square root of negative 1 times the square root of 5. Here we have a square root of a negative 1. We know we call that the letter I. So I replace that with I, and it's the square root of 5. So this is another imaginary number. Here they want to know, for this quadratic equation, what are the two solutions? Remember, solutions is another word for roots or zeros or x-intercepts. So we just come on in and solve this. Nothing new from what we just saw. I'm going to take the square root. Because I take the square root, I better put plus or minus here. So therefore, x equals the square root of plus or minus negative 7. Now be careful, negative 7 is the same as the square root of negative 1 and the square root of 7. So this now simplifies to the final answer of plus or minus I times the square root of 7. So this quadratic, as most do, have two unique solutions right here. So now we're going to go and talk about that complex format. So we've addressed the imaginary format, which is right here. So all a complex number is a combination of real and imaginary. So down here we have two different complex numbers. This one is a negative 11 plus 8i. They want us to name the real and the imaginary parts of this number. So for part A here, the real number listed is negative 11. The imaginary number is the 8i. Now for part B, the real number listed is the 5. The imaginary number, there isn't one there, but it's really there. It's just 0i.